These are the continuation of whatever we have stopped in the last video. Alright, look at the sixth one. We have find the maximum value of this function in the interval 1 comma 3 and in the interval -3 comma -1. Right? Now, first is what? Differentiate, get the points of inflection. Right? So, f dash of x becomes 6x square minus 24. Now, equate this to 0. So, you will get 6x square is 24, x square is 4, x is plus or minus 2. Now, see the interval x is equal to 2. This lies between 1 comma 3. Yeah. And x is equal to negative 2 lies in between -3 comma -1. Isn't it? So what do we do? First, we are going to take this 1 comma 3 interval. Next, we are going to take this -3 comma -1 as the interval. Then we'll check the maximum values. How do you check the maximum values? You're going to take the value of x, substitute in this f of x equation, isn't it? So this is the whole process of how we are going to solve this one. Fine. Let's do the math now. First, we'll take the interval of 1 comma 3. That means here you have x is equal to 1, which is the first point. X is equal to 2 because that's the point, the turning point or the point of inflection. And x is equal to 3, one more extremum value in the interval. So first we'll do f of 1. So 2 into 1, 1 cube is 1, minus 24 plus 107. So this if you do, you'll get it as 85. Yeah. Next we'll do f of 2. 2 into 2 cube minus 24 into 2 plus 107. Correct? So this if you do, you're going to get the answer as 75. Now the next one is f of 3. 2 into 3 cube minus 24 times 3 plus 107. Correct? So here you have 27 times 254 and all you'll get. Right? So now this if you solve, you'll get the answer as 89. Now look at these three values. Of this, the maximum what you have is 89. Correct? That means within the interval 1 comma 3, you are going to get f of 3 or maximum value of f of x in 1 comma 3 is 89. This is going to be the first part of the problem. The second part of the problem is where you have to go from -3 to -1. In this, the turning point is -2. Correct? So we'll finish that one. Interval is first is -3, -2, -1. Yeah. Now you have f of -3 will be 2 into minus 27. Let me write it directly. Next, plus 72 plus 107. Correct? So the value of this is going to be 107. Yeah. Next, f of -2 is going to be 2 into which one is -16 plus 24 times 2, 48 plus 107. Correct? And the value is 139. All right. Then f of -1, which is -2 plus 24 plus 107. Right? And this is 129. So see the maximum value. This is going to be 139. Because what you know is whenever you substitute the points, you have to get the maximum value. That is the whole point of the problem, isn't it? So what do we write at the end here? So we can write the maximum value of f of x in -3 comma -1 is 139. So this is how you solve the sixth one. Fine. Let's do the next seventh one. The seventh one, find two positive numbers x and y such that x plus y is 60 and xy cube is maximum. See, what do we know? X and y. So x plus y is 60. And you need to maximize their product xy cube, correct? Say we'll take p is equal to x into y cube. Yeah. Now you can write, say y is equal to 60 minus x. So the product is going to become, or maybe you know what, x doesn't have a power. Maybe we can swap this one. That means instead of y is equal to x minus 60, maybe we can take x. X is equal to 60 minus y. This makes things a lot more easier. So you have 60 minus y into y cube. Yeah. The product will become 60 y cube minus y power 4. Differentiate this and we'll get the turning points or the points of inflection. So what do? Differentiate with respect to y. You'll get 60 into 3, 180. 180 y square minus 4 y cube. Yeah. Now equate this to 0. So you will get 180 y square minus 4y cube is equal to 0. Correct? Now you can take 4y square as common. See, if you take 4y square as common, 180 divided by 4. So you can take, so 180 by 4 is going to give you 45. Yeah. So 45 minus y square. 45 times 4 is basically 180. Is 0. So when you take y square, this is going to be y. Sorry, this is going to be y. Now, either y square is 0 or 45 minus y is 0. See, y is equal to 0 or y is equal to 45. Now, it's very clear that y can't be 0. Anyway, we are going to prove it later on. But it's quite obvious y can't be 0. Okay. Now, let's look into the next part. Second derivative test, because we need to get maximum, right? So for maximum, second derivative should be negative, correct? So let's take this dp by dy, differentiate it again, and let's try to figure out what is the second derivative and how we are going to get it. Yeah. Now you have 180 y square minus 4y cube. So let's do the second derivative test. Have dp by dy is 180 y square minus 4y cube. D square p by dy square is going to be 360y minus 12y square. Two values we have. One is 0, one more is 45, correct? So put the values. Suppose if y is 0, then second derivative is going to be 0, correct? Suppose if you take y as 45, then d square p by dy square will become 360 times 45 minus 12 into 45 square. Correct? So here you can take 45 as common. So 360 minus 12 times 45. Okay, you don't, guys, remember one thing, you don't have to multiply and get the answer. Try to take it common because you're trying to prove that it is negative. You're not actually trying to find the value, isn't it? So what you do here, you can write 360 as 45 times something. Okay, 45 times something. So what you can write 360 as 45 into, try to think of the xy coordinate system. Okay, try to think of that one. So when you take it, you're going to get 45 times 8 minus 45 times 12. So take 45 common. 45 square into 8 minus 12. See, this is less than 0. That's all is required. You don't have to figure out the value. So since you know that this is less than 0, you know that y is equal to 45 is where the value will be maximum. Correct? So now what do? You put that y as 45 here. Once you put y as 45 here, then you can get to know the value of x. I think just by looking only we can tell, right? So what do we have? Y is equal to 45. So x is equal to 15. So 15 and 45 are the values where the product, that is xy cube, is maximum. Fine. This is how you solve this one. Do the first derivative, get the points of inflection. Then use those values and then do the second derivative test. Find for which value it's maximum. Then you will get to know the answer. Fine. Now let's do this next one, the eighth one, which is very similar to this one. Exactly the same, only the variables are changing. I mean, the function is changing. Let's do the eighth one now. Positive such that x and y, their sum is 35. So x plus y is equal to 35. The product x square y power 5 is maximum. See here, unlike the last question where you had the power of x as 1, which was a lot more easier to solve. But here you have x square and y power 5. So it's better if we substitute x value, correct? So what do we have? X is equal to 35 minus y. Substitute. So product P becomes 35 minus y whole square into y power 5. Yeah? Expand. 35 square. 1225 plus y square minus 70y into y power 5. Now, take this 1225 into y power 5 plus y power 7 minus 70 y power 6. This is your product. Now, differentiate and try to figure out the value of y. In the sense, do first derivative test, get the value. Don't worry, you most of the terms will get cancelled anyway. Even though you have y power 7 and all, don't worry about it. So, do dp divided by dy will be 1225 into 5 y power 4, 7 y power 6, 70 into 6 y power 5. You have to equate it to 0, correct? Now, when you're equating it to 0, try to take common. Yeah. See, one thing what you know, you can take y power 4 as common, which is a lot more easier. Into. Now, 1225 is 35 square. So, write it as 35 into 35 into 5 plus 7 y square minus 35 into 2 is 70, correct? Into 6y. You're taking it common. That's all you're doing. You can take 7 common. That's the only thing what you can take common. So 7y power 4 into 35 is 7 into 5. So you'll get 5 into 5 into 35 plus y square minus 5 into 2, 10. 10 into 6 into y is equal to 0. Okay. Now 7y power 4 is 0. Like you can just ignore that value because y can never be 0. So this term is gone. So what do you end up with? Y square minus 60y plus 25 into 35, correct? Is equal to 0. Right? So we'll multiply 25 and 35. dp by dy y square minus 60y plus 5 is equal to 0. Right, now we need to split the term in such a way that we have to get two values, correct? So let's do this one now. Remember, you can use the formula if you want, or you can just think of numbers which you can split it properly. Fine. As y square minus 35y minus 25y plus 875. Correct? So when you do this, you'll get it as y minus 35 into y minus 25 is equal to 0, like at the end. So you have y is 35 or y is 25. Now comes the second derivative test, because you need to prove that second derivative is negative for it to be maximum, isn't it? Now what do we do? Second derivative, it's very easy to figure out the second derivative. So second derivative d square p by dy square is 2y minus 60. Put y value as 35 first. So if you take 35, what do you get? 2 into 35 is 35 into 2 minus 60. 70 minus 60 is positive. 70 minus 60, this is greater than 0. So discard 35. So check for 25. Obviously, it's going to become negative. But still, if you take y as 25, you'll get 50 minus 60, which is less than 0. Sorry, less than 0. Correct? So that means our value is what? Y is equal to 25. Isn't it? So at y is 25, the x square y power 5, the product is going to be maximum. So what do? We take this y as 25 and we'll substitute back in the particular formula. Formula in the sense the function. Which function are we going to substitute? We'll substitute their sum is 35. Correct? Since the sum is 35, so maybe we can just write it here itself. See, what do we have? Y value is 25. So x value is going to be 10. Correct? So y is 25, x is 10. So this is the answer for the eighth one. Clear with this? So these are the type of problems. Now in the next video, we'll look into the geometry and mensuration type of problems. Fine?